In this presentation, the testing of hypothesis for 1 and 2 population variances is to be described. Testing of hypothesis for one population variance can be done by using chi-square distribution, and testing the equality of the two population variances can be tested by using the F distribution. The F distribution and the chi-square distribution. In this presentation, we have to describe these two. In the first video, I will cover the chi-square distribution, and then in the next video, I will record F distribution characteristics. The chi-square distribution is what? Initially, I was describing the distribution of the sampling distribution of mean. So in this video, we are not going to describe the distribution of the sampling distribution of mean. If we have mean as a variable and the probabilities we have, probability of X bar, then this is called sampling distribution of mean. And in the previous videos, initially we have studied the characteristic of sampling distribution of mean. First characteristic is the mean of the sampling distribution of mean is equal to the population mean. The variance of the sampling distribution of mean is equal to population variance divided by n, sigma square X bar. It is equal to sigma square upon n. And then we have a third characteristic. Sampling distribution of mean will be approximately normal if the sample size is large, for n is large, 30 and above. So these are the different characteristics of sampling distribution of mean. Instead of computing the mean of each sample, if we calculate the variances of each sample, suppose the variance is a variable and the probability of variance we have, then all values of the sample variances which are unique, I should write down here, and their probabilities are to be recorded in the next column. This is called sampling distribution of sample variances. Sampling distribution of sample variances, if I construct a transformation, and that transformation is n-1 times s square upon sigma square. This column will follow chi-square distribution. So this is the formula for chi-square distribution, and this is the distribution which we can say that the sampling distribution of sample variances. As we have a z column here, X bar minus mu sigma upon n root, which is a normal distribution, sigma upon n root. In the same way, if I construct this transformation n-1 times s square upon sigma square, then this transformation will follow a right skewed distribution named as a chi-square distribution. So in the first part of this lecture, we have to complete the characteristics of the chi-square distribution. So this is the variable which is named as a chi-square variate or the chi-square variable. It is a random variable, and the probability distribution of this random variable is referred to as a chi-square probability distribution. Chi-square probability distribution have certain characteristics. So these are the properties of chi-square distribution. The area under the chi-square distribution is always V1. This characteristic is a generalized characteristic which hold for all of the probability distribution. The chi-square curve starts from 0 on the horizontal axis and extend to its infinity to the right. So the shape of the distribution is like this. We have to start by 0 and move to the right hand side up to the infinity. It has a horizontal asymptote because it never touches the x-axis. So we will be closer and closer to the x-axis, will never be touching the x-axis. This is called the horizontal asymptote of the distribution. Chi-square is a right skewed curve, and chi-square becomes approximately normal if the size of sample is increased. Suppose if we have a large sample, then the distribution of chi-square will be approximately to the normal distribution. So these are the few characteristics of chi-square distribution. Chi-square distribution has four specific usage. Number one, it is used for testing of hypothesis of one standard deviation. One standard deviation means, suppose someone is saying that the standard deviation of population is equal to the 5. So we are comparing the population standard deviation by a number, as we were doing in the hypothesis, like mean is equal to some number. The first hypothesis where we started the testing of hypothesis procedure, the mean is 50 or the 50,000. Suppose the average salary in my population is 50,000 or 50K. So that is the null hypothesis, and we are here to test the hypothesis regarding the one standard deviation. So the first application is very simple. In the first application, the population standard deviation is to be compared by a single number. Test of independence of two factors. Factors means the qualitative variables. So if we have two qualitative variable and we want to check the independence or the in that two qualitative factors, that can be checked by using the test of independence. Suppose we have a one variable, the gender, and the another variable is the grade. So whether the grades are gender biased or not, the null hypothesis will be the grade and the gender are independent. And the alternate hypothesis will be what? The grades are associated with gender. So that will be the alternate hypothesis. This hypothesis can be tested with the help of chi-square test of independence. So this is a qualitative application of chi-square. So this is a quantitative application. This is a parametric test. This is a non-parametric test. Third characteristic is the third usage of chi-square distribution is the equality of several population proportions. If you want to compare the proportion 1, proportion 2, suppose people are there are the several soft drink companies, and H naught is the soft drink, the proportion of the soft drink user by company 1 is same as the proportion of soft drink users of company 2 and is equal to the proportion of the soft drink user by company 3. Suppose there are 3 companies and company 3 is claiming that they have a market share. They are the large, their proportion is very high. P3 is claiming that. So that will be in alternate hypothesis, whether not all the 3 companies have equal proportion in the market of their customers. The fourth application is the test of goodness of it. It is a testing of the model. As in the early classes, I taught about the model. Models are fitted and the models are tested. The model can be tested by using the goodness of it, which is an application of chi-square distribution. So this is a quantitative test. This is a quantitative test, number 1. Number 2 is a qualitative test. Number 3 can be qualitative or can be quantitative, but it is proportion is used for a qualitative variables, like companies, proportion of companies is a qualitative variable we have. So these are the 4 important application of chi-square distribution. In this video, I will consider only the first application, which is sigma is equal to sigma naught. Before going to start this first application, I introduce the details of this test of chi-square for one standard deviation. chi-square, how can we obtain the critical value or the p-value of the chi-square distribution? This is described here in this slide. So the degree of freedom is 7, and we are interested to obtain this critical point from a chi-square table at the level of significance 0.05. The level of significance is 0.05, degree of freedom is 7, the size of sample is 8, because if the size of sample is 8, then the degrees of freedom will be 7. And we have to take this value of chi-square statistics from the chi-square table at 0.05 level of significance. So I'm demonstrating it into the table, and from the table we obtain this value. So our objective is to take a value of chi-square statistics at 0.05 on the left side of this point, and we have to obtain this point, which is named as a critical point of the chi-square curve. Degree of freedom was given to the 7, df was 7, and the 0.05 was the value of alpha. Alpha is equal to 0.05 and degree of freedom is 7. The graph is showing what? The graph is showing that whatever the value of alpha on the right hand side, you have to plug in here. So the value of alpha, which I have to look up into the table, is not 0.05. This value will be the 0.95. So if we are considering this column 0. No, not this column 0.95 at the degrees of freedom 7, I have this number 2.167. So 2.167 is the value of chi-square distribution or the chi-square variate. And the critical region will be what? The critical region will be, critical interval will be 2.167 and from 0. And the 0 is inclusive. This interval is known as the critical interval for the, if the value of the chi-square observed test falls in this region, then our conclusion will be in favor of H1. So H0 is rejected. If the value of chi-square observed falls in the 2.16 above more than 2.16 or above, this is called acceptance region. Acceptance region is from 2.167 up to plus infinity. So this is the acceptance region. If this chi-square value fall in the acceptance region, we will accept the null hypothesis and our conclusion will be in favor of H0. So you can see that the value is 2.167 is the value of the chi-square variate. In this example, we have to determine the two critical points. The alternate hypothesis will be not equal to, and we have to obtain the two critical points because the two-tailed test is to be used in some examples. This number can directly be obtained because according to the chi-square table, you can directly look up the right value. But whenever we are looking at the left value, so we should have to provide this area to the chi-square table. That is 0.975 at 20 degree of freedom. So we have to look up the two numbers from the chi-square table. One is the 0.0 for chi-square, 0.05, 0.025 at the degrees of freedom 20. This number can directly be obtained from the chi-square table, but the number on the left side is written as chi-square. Instead of 0.025, I have to write down as 0.975. 0.975 with the degrees of freedom 20. So these two numbers are to be obtained from the chi-square table. So chi-square 0. 0 to 5 at 20 degrees of freedom. This number is needed. So 0.025, it can be directly be used because 0.025 is this region. At 0.025, 20 degrees of freedom, 20 degrees of freedom is this. But 0.025 is not here in these columns. So I have to switch to the next screen or the next page of this table. Here we have 20 degrees of freedom. Against this 20 degrees of freedom, 0.025. This is the 0.025 in the middle column. This is the number which is on the right side we have. So this number is what? This number is basically the number of this critical point, 34.17. The second number which is needed is chi-square. 0.975 at 20 degrees of freedom. Because whenever we are looking this number, this region is 0.025, but we have to input to this right hand region, which is 0.975 at the 20 degrees of freedom. This can be obtained by looking 0.975. This is 0.975 at 20 degrees of freedom. 20 degrees of freedom is this. The number in the middle column is 9.591. So this number is what? This number is 9.591. So what will be the critical interval? Critical interval will be 9.591, comma 0 with the union 34.17, comma infinity. This region is referred to as critical region. The critical region will be used if the observed value of chi-square test falls in any of these intervals, either in left interval or in the right interval, we will reject the null hypothesis. And the conclusion, if it's fall in the left interval, we can say that population standard deviation is less than some number. If it is rejected from the right hand region, our conclusion will be the population standard deviation will be larger than this number. These are the two conclusions. If observed value falls here, then alternate hypothesis will be this. If we rejected the null hypothesis by right interval, the final conclusion will be population standard deviation will be larger than sigma naught. So 9.591 is the value of the left critical point, and 34.170 is the value of the right interval. The middle interval is known as the acceptance region, and acceptance region will be 9.591 with the round bracket. Why round bracket? Because this is not included in the acceptance region. Up to 34.170 with the right bracket, because 34.170 is not included in the acceptance region. So if chi-square observed value falls among this region, our conclusion will be the null hypothesis will be true, and we have to take the decision according to the null hypothesis. This is procedure T9. In this procedure, the null hypothesis will be sigma is equal to the sigma naught, with the three options of sigma is not equal to sigma naught, alternate hypothesis, or sigma is less than sigma naught, or sigma is greater than sigma naught. Depending on the situation, we have to set any of the alternate hypothesis. These are the two major assumptions. The simple random sample, that if the data is not random, we cannot apply this chi-square distribution. And the second assumption, which is quite interesting, chi-square distribution itself is a right skewed distribution, but the data from where we have selected the sample should be normal. The population should be normal. So we first have to check the normality by any of the procedure described earlier. One of them is normal probability plot. If the normal probability plot is linear, so we can say that the population are normal. So it is quite interesting. The population should be normal to apply this test, but this test itself is a right skewed test. Second step is simple. You have to decide about the level of significance. It is 5% generally. If it is not provided to you or not specified, then the chi-square test degree of freedom is n minus 1 s square upon. So it is quite simple to remember. This test is a ratio of sample variance to the population variance multiply by degrees of freedom. So that is quite simple way to recognize this formula. This formula is referred to as the chi-square test or the chi-square observed value. Remaining procedure is simple and usual. You have to either set the critical numbers by any of the three ways: two tail, left tail, right tail, or you have to pick a p-value from the table, and if p-value is less than or equal to alpha, reject the null hypothesis, otherwise accept the alternate hypothesis. And finally, you have to write down the conclusion. Now, one complete example is under consideration. These are the values of the weights of capsules. The capsules are produced and the weights of the capsule are given here. What is to be tested? You have to test whether the standard deviation of the weights of these capsule is less than 2 milligram. The standard deviation of all produced capsules is a standard deviation of population, and it is smaller than 2 milligram, 2 mg. So this is the alternate hypothesis in which the researcher is interested. The researcher is claiming that the production line is very accurate, and it is giving us a disparity or the differences among the weight of the capsule, which is less than 2 milligram, which have a smaller than 2 milligram standard deviation. So H naught will be what? H naught is sigma is equal to 2 milligram. Alternate hypothesis is sigma is less than 2 milligram. So we first have to check the normality of this data by constructing normal probability plot. Then we will apply chi-square test if the data is normally distributed. And the first assumption is already given in the problem. The sample is assume that that sample is a random sample. The data should be random and data should be normal. So these are the two assumptions that must be checked. So before going to start the test, it is linear, normal probability plot is constructed, null and alternate hypothesis in step number 1 are given, alpha key value 0.05, it is not specified. If it is specified, so you have to use that specific value. So this is 0.05. The value of alpha is 0.05. This is the chi-square test observed value. Observed value can be computed by just calculating the standard deviation of the population. So this is not a standard deviation of the sample. So this is the variance of the sample. The variance of sample can be computed by just the variance of these numbers. The variance of these numbers, sample variance of these numbers is computed. Now the value of chi-square is degree of freedom n minus 1. sigma square, S square is 1.113 divided by sigma square is 2.0 whole square. The value of chi-square observed, chi-square observed having a value of 2.54, 504, 2.504. Now we have to either critical region or the p-value. The critical region is used here. The region, shaded region is on the left. So what is to be look up into the table, not 0.05, you have to look into the table. So you have to look 0.95 on the 9 degree of freedom. This number is to be checked into the chi-square table and obtain a critical point that is 3.325. So your critical interval, not a confidence interval, it is a critical interval. Critical interval is from 3.325 and with the square bracket here, because it is a closed bracket, 0. This is the interval where we have to reject the null hypothesis. Our observed value of chi-square test was given on the previous slide. The chi-square observed value was 2.504, 2.504, which lies in this interval because it is from 0 to 3.3 to reject the null hypothesis. Rejection region, reject H naught and conclude that all capsules production weights having a standard deviation which is smaller than 2 milligram. The variation in capsule weight is acceptable according to the US standards.